Okay, so this lesson is on analyzing graphs. We're basically using all the vocab that we've been talking about with functions. So we're going to talk about, is the graph that's given discrete or continuous? We're going to name the domain and range. We're going to tell if it's a function or not by the fact if it passes the vertical line test or not, and then the zeros of the functions if there's any. Okay, so the direction says, given the graph below, write a description in words, use the elements of the vocab list below. Be very descriptive as if you were teaching someone how to analyze the graph. So for example, like the vocab where it says discrete or continuous, well, we know that this is a continuous graph because it's connected. There's no stops, jumps, or holes. Basically, it's like a checkoff list. Well, we know it's this one, it's not this one, so let's write a sentence that it's continuous. So we could say, the given graph is continuous, or we'll say is a continuous graph because there are no holes, jumps, or gaps. Okay. Now if we look at the next part, let's just do a little work. Let's talk about the domain and let's talk about the range. Now if you remember, the domain are all the x's. So we're going to swipe from the left and from the right. And if you notice from the left, we hit the arrow, which means it's going to continue to go on, and eventually the x's are going to reach negative infinity, okay? And the range on the right, when we swipe from the right, we hit the arrow up here, which again, as it continues, eventually all the x's are going to get to positive infinity. And we've talked about any time you have a span of numbers from negative infinity to positive infinity, that covers all real numbers, okay? Now the range, we know are the y's, so we're going to go from bottom to top. So from the bottom, we hit this point, and again with range, we only care about the y, and the y value is -3. So the lowest y value is -3, and since it's a solid line, this is a solid point, so we use the square brackets. Then on the top, we hit the arrows, and again, that means that it's going to continue to go up, and we know y, if it goes up forever and ever, it's going to reach positive infinity. And since the positive infinity represents the bulk of the y's, well, we basically say, well, is y bigger or smaller than -3? Well, we know that it's going to be y is greater than or equal to -3 because positive infinity is bigger than -3, okay? And we use the or equal to for the solid points, which are found on the solid line. So we can say the domain of the given graph is all real numbers and the range, we'll just say is y greater than or equal to -3. Okay, so basically check, we're done with this. Now, is it a function or not? We're going to use the vertical line test. So if I do all these imaginary vertical lines, notice each time it only hits the graph once. And if I keep going, it's going to do the same thing forever and ever. So yes, it is a function. And we know because with the vertical line test, there's no repeated x's. Okay, so let's say that. So the given graph is a function because it passes the vertical line test and no x's repeat. Okay, so check, we took care of this. So the last thing we need to basically state are what are the zeros. Now remember, we talked about the zeros, a synonym for zeros is x-intercept. And we know the x-intercepts by where the graph crosses the x-axis. So here we know x is -1 and 2. And if we actually wrote the coordinates of this point, now again, remember this is review, this coordinate would be -1, 0, and this point would have the coordinates 2, 0. Now, the point I'm trying to emphasize is that both y's are 0. That's where this term zeros come from, because the y's are 0. Okay? So, we know, we can say the zeros, or x-intercepts, because it's good to state the synonym, of this graph are x equals -1 and 2.